Okay, today we're going to talk about factoring polynomials using the difference of squares method. What we're first going to do is we're going to start off by reviewing a little bit of concepts in terms of multiplying two binomials together and seeing what we receive. So let's take a look at the following example of x plus 4, x minus 4. Here's what you want to take a look at. When you multiply these two binomials together, what you should realize is that the first term is going to give you x squared, the outside is going to give you minus 4x, the inside is going to give you plus 4x, and the last two terms is going to give you minus 16. What you really want to key in on here is this piece when we distribute. And this piece here, well, minus 4x plus 4x, that's 0. So what we're left with here is x squared minus 16. Okay. What I want you to kind of do is I want you to keep an eye on these two pieces here as we move forward through a couple of different examples. So that was the first example. Let's take a look at another example here, kind of utilizing the same method. And maybe we can start to pick up on what's happening. Okay, second example, let's see. Let's do 5x plus 1, 5x minus, what did I say, 5x plus 1 here, 5x minus 1. So when I multiply these out, the first term I get is 25x squared. Outside would be minus 5x, inside would be plus 5x, and the last term would be minus 1. Okay, and again, let's key in on what's happening here in the middle here. Minus 5x plus 5x, well, that's 0. So my final answer here is 25x squared minus 1. Okay. And again, this little pattern seems to be repeating itself. Okay. So what we're going to talk about today is we're going to talk about factoring polynomials. Okay. So working backwards here. So taking our problem and breaking it down. So in order to factor a difference of squares, the general rule is if we have a squared minus b squared, what we're able to do is we're able to rewrite this as a plus b times a minus b. And that would be take the square root of this piece here and take the square root of this piece here. And that gives you a and b. Okay, so what we're going to do is we're going to take a look at a couple of examples here. You can pause the video and write this general rule down. But let's just say we were given the term or the binomial a squared minus 4. Okay, so if we have a squared minus 4 and we're following our general rule here, well, we're going to take the square root of a squared, and I know that is a. And we put a plus here and a minus here. And then we take the square root of 4. And the square root of 4 is 2. And we're done. And what we'll see here is if we were actually to go to take this piece, if we were to take this and we were to multiply it out, well, we'd get a squared first. Outside would be minus 2a. Inside would be plus 2a. And the last term would be minus 4. And again, take a look what's happening here in the middle. Those terms cancel out. What you're left with is, well, a squared minus 4, and that makes sense. Okay, so that's how you can go back and check to make sure that you actually factored your problem correctly. I'll do a couple more examples. Okay, so let's see, n squared minus 64, n squared minus 64. Okay, the square root of n squared is just n, so I can write that piece. I know I have a plus here and a minus here. Well, the square root of 64 is 8, and that is your final solution. So this is actually your final solution here. This is factored. This is the factored form. Okay. And again, I'm going to try to go through as many examples as I can of different types of problems you may see. Okay, there goes another example. Let's see, 81 minus x squared. Now, before I go ahead and go through this one, I want you guys to take a note of something here. And what you should be realizing is that Well, our variable is no longer first, so that kind of changes up a little bit. Our variable is no longer first. We have the 81. So what we'll do is, because 81's first, we take the square root of 81, and that would be 9. Okay, plus, minus, like always, and then we take the square root of x squared, and the square root of x squared is just x. Okay, so we have 9 plus x, 9 minus x, and I'll FOIL this out just to show you what happens. 9 times 9 is 81. My outside term is minus 9x. My inside term is plus 9x. And my last term is minus x squared. Well, in the middle we have minus x squared plus 9x, and that's 0. So we're left with 81 minus x squared. And that's exactly what our final answer is. Now let's take a look at this example. We have k squared plus 25. Okay, now the rule said we needed to have an a squared minus a b squared. So right off the bat here, you should begin to notice something, and that would be this sign right here. Because you have a plus 25, this makes this binomial non-factorable. So if we can't factor that and it doesn't follow the right rule, we call this prime. Okay, so be very careful here in terms of being able to factor this. You can't factor this problem right here. So when we call something that we can't factor, we call that prime. All right, I'm going to do 3 more different examples. Let's see here. 25x squared minus 49. Okay, again, we have the minus sign, so we're good here. The square root of 25x squared, well, that is just 5x, okay? 5x times 5x is 25x squared. That makes sense. And we have our plus, we have our minus. Square root of 49, well, that's just 7. There goes your final answer. Okay. Now what we want to see is, let's take a look at one a little bit more challenging. 18x squared minus 50. Okay. Now you're going to have to think back a little bit to before spring break, which I know was a little while ago, but let's take a look at one like this. 18x squared minus 50. And before spring break, we're factoring using the greatest common factor. So step 1 is to always look to see, with whatever you're factoring, is there a greatest common factor? Okay. And in this case, there is a greatest common factor. And in fact, they both happen to share 2. So if I take a 2 out of both of these, what I'm left with is 9x squared minus 25. Okay. So I pulled my greatest common factor out. That's very important. And now I'm going to take a look at this here. And what I need to notice about this piece right here is that this is actually a difference of perfect squares as well. Okay, so this difference of perfect squares, I can then factor that even further. Okay, and the square root of 9x squared is just 3x. Okay, plus minus the square root of 25 is 5 here. 5 and 5. And that is actually my final answer. That is my final answer. So again, just to recap here, you want to make sure that you are looking for that greatest common factor first. Very important that you pull that greatest common factor out, and then go ahead and take a look back at the beginning or the rest of the problem to see if what you have left you can factor. And then with what you have left, if you can factor that, you want to go ahead and make sure that you factor that down even further. Just because you factor once does not mean the rest of the problem is not factorable. So always make sure you go back and take a look at that. I hope this video helped you guys out. Always message me if you have any questions.